Hi everyone, and thank you for joining. We are about to start in just a few minutes, so you have some time to get comfortable and maybe to grab a cup of tea or coffee. Let's check that everything works properly. If the sound and the video are working fine, please type a plus in the chat so we could check the connection if everything works. Okay, I see that the sound is okay. The video is also okay. So I believe we can start, and it's time to get to know each other a little bit better. I'd like to introduce myself. My name is Christina. I'm partnership manager at Ispirer. I work on partnership relations and also marketing activities, joint marketing activities with our partners. And today I am the host of this session, and I'm super excited about this opportunity and glad to meet you all. Also, here we have Alex with us. Alex is the head of database migration department, and he's the speaker of this session. Hi, Alex.
Hi, Christina. Hello, everyone. Thanks for joining today.
I know that many of you know Alex already, but Alex, could you please share a few words about yourself?
So, my name is Alex. Yes, I'm a head of database migration department at Ispirer. So, I'm responsible for database migration services and development of our internal products. So, yeah, nice to meet everyone.
Alex, thank you so much for this introduction. Guys, now it's your turn to introduce yourself. Please share some information about yourself, for whether you are a customer or a partner or someone who is interested in data migration. Also, you could share your expectations from today's session. Alex, by the way, what's your expectations from this session?
So my only expectation is that as many people as possible will appreciate our new solution because we believe it's totally worth it. Yeah.
Thank you, Alex. I need to check the chat box. Okay, people still writing that everything is good. And hi, Alex. They're also welcoming us. And please share some information about yourself. Is you a customer, a partner? We are looking for this information. We would like to know our audience a little bit better. Okay, I see one comment. Expectation is to hear about the solution overview as a possible partner. That sounds really great. For those of you who are new to Ispirer, I'd like to give a quick overview of the company. We are a technology company with over 27 years of experience in IT modernization. We specialize in database migration across multiple platforms and also in application modernization, moving legacy technologies moving from legacy technologies to modern stack. And we have a set of tools. We have InsightWays for database analytics. We have also SQLWays for database migration, CodeWays for application conversion. And you can use these tools for your migration projects, or we can handle the migration project as a service. Actually, it's the time to tell you about the solution, and I'd like to handle it over to Alex to introduce IDM for you. So, Alex, this stage is yours. Please tell us about the solution.
Yeah, thanks, Christina. So today I'm going to demonstrate a new solution for migrating large amount of data and replication. So at the moment, this tool called IDM is available only for Oracle to Postgres, but we have big plans for development and expansion these tool capabilities. I'm sure that you will be very interested in what you will see, and you will definitely want to try it, to try our new product in action and find out how to use it for your migration projects. So first of all, we will explain the main features and principles of solution with a few slides, and of course later I will demonstrate it. So let's not keep everyone waiting and get started. So Christina, let's move on to the next slide, and let's explain how does our solution work. The principle of process is iterative. So this slide shows a diagram of how the tool works. The main approach is that we do not replicate transactions. We repeat the consistent state of data and to the certain point of time. The result of the iteration will be a consistent state of data in the Postgres database, which was in the Oracle database at the start of iteration. So the first iteration, this is like a classic snapshot. As a result of the first iteration, we will have the data that was in Oracle at the start of the process. Of course, the first iteration is the longest one, and it can take a significant amount of time in case of large amount of data. Immediately after finish of first iteration, the next iteration begins automatically. It will reproduce the state of the data in Postgres at the moment the second iteration begins. So our tool determines which data has been changed in the source database during the previous iteration and make appropriate transformation in PostgreSQL. As iteration progresses, the time it takes to check the data and make changes is reduced, which ultimately leads to the stable iteration time. So this is replication log. And our tool guarantees consistent state across the entire scope, at least at the end of the iteration or in any period of the time. So I will explain about it later. And accordingly, by monitoring the process and knowing the iteration time, we can understand the replication lag and downtime if we are talking about one-time database data migration process. So now let's talk about the features of the solution and advantages of our approach over other similar solutions. Next slide, please. So the main idea that we have created an algorithm and CDC solution that does not rely on reading and parsing transaction logs or reader logs. This is our own development, which allows us to identify changed data and replicate changes in the target database. That's what differs us from any other migration solution with replication. So, couple of more important points you need to understand. So, you don't need to change the setting of the source database in any way, or reconfigure the server, enable logs, or allocate additional space for logs. Based on our tests, the load on the source server is significantly lower than in the case of replication using standard log-based technologies. This makes our IDM solution an extremely attractive solution for critical projects where DBAs or rules do not allow any changes in the source server settings. and where performance is critical. In addition, the connection to the source database made is in read-only mode, and user will with really low read privileges is required for this process to work. So IDM is deployed entirely on PostgreSQL side. We only use PostgreSQL resources to control and perform migration and replication. You don't need to install any additional server or open network access to this additional server. Data is migrated straight from source to the target, and we utilize resources of Postgres. In case of one-time data movement, data migration, we will utilize resources of at the later stages production PostgreSQL server for migration itself, which from our perspective is really convenient. Yeah, unlike most migration tool, our tool does not slow down the speed of migration of binary data, which is also a really great advantage of this solution. So all PostgreSQL server resources that we allocate for migration will be automatically distributed among all tables in the scope. Users also have the ability to change a lot of settings, and these settings will affect on the load of the target server, and you can control how many resources our tool is consumed. So it's also important to note that IDM solution does not have any bottlenecks on architecture level. The speed of migration is totally dependent only on capacity of Postgres server and a little bit on capacity of Oracle server, of course. Next slide, Christina, please, and let's continue. So a couple of more additional features. IDM does not care about whether your table has primary keys or not. There is no requirement like have unique key or unique column. You don't need to change your source database in any way compared to classical read-only solutions where primary keys is critical, and without primary key or unique constraint, you will not be able to run the process of replication. The migration and replication is totally and fully automated, and this process runs on background. There is no need to have an active connection to Postgres, and also in case of any problems like network issues or server shutdowns, the process will automatically resume from the point where it stopped. Additional points which you need to understand that even if the first iteration lasts for days and weeks and something interrupts it, we will not lose any progress. IDM can handle such scenarios, and of course, you understand that in case of huge systems like hundreds of terabytes of data, the process of snapshots, these first iterations can take like weeks or days, and it's really critical if you lose our progress. So for IDM, it's not a problem. We will not lose any progress, and process will automatically will be starting from the point of interruption. For example, you can check it if you will run our IDM solution and shut down your source or target server. Then as soon as you will turn it on again, the process will automatically be resumed and you will not lose any activities at all. And of course, we have an integration with our SQLBase main tool for code and schema conversion, and we have any opportunities on transforming data on custom mappings in terms of names of tables, columns, data types, and so on. So I believe we can continue, Christina. So what do we need to start using IDM on your system? Christina, can we switch to the next slide, please? Yeah. But before we read, let's speak about how we can utilize such kind of solution and this approach. So, of course, first of all, why we created this tool? This is because our main plan is to use it for one-time database migration project. When possible downtime on source server is really low. We need to have solutions that support CDC in order to perform it within a couple of hours. So that's the main reason why we created, but this solution can also be utilized for some other possible ways, like create CDC just for reporting services. So near real-time CDC is possible. This solution is stable and it will be working on background for hours and days as you wish. And now let's speak about what do we need to do to start the migration. So you should understand, first of all, that our solution uses a number of non-default PostgreSQL extensions. On the slide, you can see this list. So we are using Oracle FDV just to connect from Postgres to Oracle. So we utilize an FDV technology, FDW. From our perspective, this is really fast and high quality technology. And this allows us to connect straight from Postgres to Oracle and move the data from it. Postgres FDV and DB-Link for connecting to itself and to license server. Of course, you need to have license to run our solution. pgcron for process control, automation, and background operations. And PLV8 because part of the logic is written on JavaScript. And at the bottom of this slide, you can see the general workflow. You connect to Postgres using web-based interface, but the solution itself and the core of our tool is totally deployed and runs on Postgres. Data migration is performed directly between source and target, and you simply control the process and monitor migration using user interface. So that's the plan, how it's working. And now let's move to the next slide. Regarding limitations, where our tool cannot be used and in which situations we cannot utilize it. So there are practically no limitation. IDM works with any version of Oracle starting with version 10. Regarding Postgres, this can be local Postgres, it can be any PostgreSQL-based database or fork of PostgreSQL, and of course, all popular cloud providers and databases are supported. Like in case of Google, it can be Google Cloud for Postgres, it can be AlloyDB for AWS, it either can be AWS RDS or Amazon Aurora as well. And for Azure, we also support Azure for Postgres for IDM. So I believe it's time to move forward with demonstration, but let's pause a little bit. I give the floor to Christina. Christina, yeah, go.
Yes, thank you, Alex. It was very, very interesting and very informative. So we let you prepare for demonstrating our new solution, IDM. And while you are preparing, I would like to ask our audience to share their thoughts about the presentation. How do you find this solution? How do you find IDM? You could share your thoughts in chat or just give us a thumb up if you like the presentation, if you like the information that Alex shared with you and with us, and if you're ready for seeing how it works. Just a few seconds, please. I'll ask just a few seconds, please. Just we are preparing to show you how it works. And okay, I'm seeing the chat. Okay, super, sounds great, that's cool. And I forget to tell you that at the end of the demonstration, we will have a QA session. During this QA session, you could ask your questions. Please write your questions in the chat so we could address them at the end of the session and after the demonstrating of the tool. So I believe the Alex is ready to demonstrate it, and let's go.
Yeah, thanks, Christina. I hope that my screen is visible and everyone can see what I'm sharing right now. So let's start demonstrating our new tool, IDM. So let's open it. This is, as I already said, user interface. The whole logic and process will be running on PostgreSQL side, but this is web-based user interface, which you can use in order to control the process, to start the migration, to see what is iteration progress, and so on. So let's start. I will demonstrate migration from Oracle to Postgres. This will be two local servers, but as I already mentioned, it's not a problem to run the same with any cloud, both source databases and target. And as well, of course, we have plans to integrate this web-based UI into all like public cloud platforms, so you will not even need to install anything and you can use it just as user interface in the cloud. So let's start. Let me show you first of all our source Oracle server. This is server where I've created a set of tables with different data types. So we will migrate 5 tables with different data types. First table with strings, next table with some numbers, table with binary data, dates, and also we have table just to show you how update is working, so it will be visible. And inside of this table, we just entered some data. We will start from small amount of data. So we just create 1,000 rows in each table, which we will go to migrate to the Postgres, and then we will start working with this data, changing it, and see how it reflects in PostgreSQL side. So for Postgres, this is also local PostgreSQL version 17, but the version is not a problem. And inside of this Postgres, I've created my own schema with the same name, but right now we don't have anything created in the target. This is totally empty schema, and we will create tables and move the data and see how it's going on. And now let's move to IDM, and let's start creating the project and running the process. So we click create project. First of all, we need to name it somehow. So let's name it webinar, and we can add description, we can change icon, and also we can change schema. We can go to dark mode, but let's skip to light. So let's create project. First of all, unlike in classical tools, we need to create connectivity to the Postgres, because the process itself will be running on Postgres. This is just for us from user interface to connect to the Postgres where everything will be running. So let's provide credentials to our source, to our target database. So let me copy our information like host, port, and so on. So this is host, port, and I will put all information. And as you can see, we have additional SSL settings if needed. And also we have button use alternative credentials for data migration. This is really needed for understanding, because the point here is next. So of course, in order to set up everything, we need to provide PostgreSQL super user privileges, super user. But actually, the migration itself can be running and can be executed with non-admin privileges. So if you don't want to run the tool and to migrate everything with admin privileges, you can provide admin privileges just for setting up the process. So we will create additional things like connections, like meta schema, and so on, but the process itself will be running and will be executed by a non-admin user. So it's possible to provide additional non-admin user, which we will utilize for running the process. And in such case, we will use root credentials only for setting up the process itself. So, but if it's also possible to just provide Postgres user and proceed. Okay, we was able to connect. Our tool also checked whether all needed extensions are installed or not, and if they will not be installed, we will provide you with appropriate message. So you will need to turn on, for example, PLV8 or some other extension, for example, in Postgres and Cloud, it's not a problem. Next, of course, you need to provide license key. Our tool will not be running without license. So this is a number which you need to provide here. This is unique number which indicate your license key. So let's click on activate. Our tool will connect to our license server and check whether this license is active. As you can see, this license allows us to migrate 100 GB of data. It's active to a couple more days, and it allows us to migrate from Oracle to Postgres. Okay, let's move on. Now we need to provide credentials to the source database. So let's also copy all information from our SQL developer, like host name, service name, and so on. So this is host. This is our service name. And also we need to provide credentials. And let's check. Click next. It can take some time. But yeah, we were able to connect to the source database. And here, right now, we can see a list of schemas and list of objects, I mean tables created under the schema, and we can check and choose which tables we want to migrate. So I will select my 5 tables, but of course, it's possible to select all schemas and click next. Now, it's an important step to set up everything properly. So as you can see here, we have a list of tables, but as I already showed you, we don't have any tables created in the target. Of course, we need to migrate in some tables. So we need to create these tables beforehand. And that's great news because actually IDM allows us to create empty structures in the target database. So you don't need to care about it beforehand. And if you wasn't able to create empty structures, you can utilize the same solution to create it. Of course, there are some limitations. Our tool will not load any constraints or indices in the target, but empty structures can be created. So if we'll click on create all, our tool will create automatically all tables and their structures. But first of all, let's create one table manually just to show how it works. So we lost our connectivity. Let's give me 1 second, please. Yeah, we create table. This is our table, which we created manually. For example, right now, if we'll click on create on table 2, our tool will say that it's already exists. So it's mandatory to create all tables, and our tool will check it. So let's click on create all. And create empty structures in the target. We see that this table already exists and these tables are created. For example, if we will click on create all one more time, we will see that all tables already exist, and that's because we already created them. So let's refresh, see that we created empty structures with the same name. Yeah, one important additional note that currently we don't have like mapping options, but it's already in the core. We just adding this to user interface, and soon you will be able to provide any names mappings how you want, and it will be work. Right now, we will create the same tables with the same name into the same schemes. But we cannot continue right now. We need to validate our tables. Validation means that we will check whether these table structures correspond to the source table structures, because of course you cannot create table with, for example, different non-correspondence data types, and for such case, we will not be able to run the process. So by clicking validate all, we will ensure that our tables are good, everything is set it up correctly, and we are ready for migration. So we clicked on validate all, everything is ready for migration, and all tables marked as ready for migrations is our scope. So on previous step, you can select 100 tables, but if you will click on validate only one table, then you will migrate one table. And also, it's important to understand that our tool also predict how many data we have in such tables. It's important for our users because if you will not know how much data you have in your tables, maybe, for example, your license will not allow you to migrate 100 GB of data, but in your tables you have like 200 GB, and your process will not be finished, and it doesn't matter for you to start the process because you don't have appropriate license. So you will know it before the process, and you will understand whether your license is enough or not. And of course, if it's not, just contact us and we will increase the license limitation. So let's click on finalize setup. You will be noted that you will not be able to change your scope after you will finalize your setup. It's important to understand that if you finalize setup, that you will not be able to change anything. And if you need to change your scope, most likely you will need to create another project, which is also possible. And this is main window of our tool. And here we will be able to run the process, to control it, to understand it, and so on. So in order to, first of all, as you can see, we have different consistency mode, and we can change consistency mode. What is consistency mode? Basically, this mode tells us what level of consistency do we have. So, for example, full level of consistency means that in the target environment, we will have only consistent state of data. So there will be no like inconsistent states, and for later iterations, for synchronization process, for near real-time CDC, it's really crucial to run in full consistent mode. Partial consistent mode, a little bit faster, but it does not guarantee that all states will be consistent. And it's good for first iterations, so you can run in partial consistent mode. The biggest iterations will be run pretty quickly, and then you will switch to full consistent mode and finish your replication and run your CDC. So let's start in partial, it doesn't matter actually. And in order to start the process, we can click start button, or we can initiate migration of separate tables. So in our tool, you can run migration of separate tables without no problem. So it's not like the full scope. Of course, it's like full scope, but you can run and stop and pause your separate tables without any problems. But let's start migration of all scope, of all tables, and see what will going on. It will take a couple of seconds to start the process. And we can see that first iteration is running. We are moving some data. And here we have a couple of blocks. First of all, this is information about current iteration, information how many data we absorted, like insert plus update, how many rows were deleted during this process. At the right pane, we can see completed migrations. This is information about completed iterations, like summary information. How many iterations were finished, how much data were migrated, what is total time, how much rows we have in current scope, what number of rows we absorted, we deleted, and what is current license limitation. Also, we have graphics on the main page telling us what is migration dynamic and, for example, iteration time based on iteration. So we can see that first iteration took us 20 seconds to complete, and then we have like really short time of iterations for every single one. And during first iteration, here on this graphic, we can see number of absorbed and deleted rows for every iteration. So look at first iteration, we insert 5,000 rows because we have 5 tables with 1,000 rows, and that's summary for all tables. After it, we didn't change anything in the source database, and we just checking whether we have any differences in source database. Do we have any transactions in source database? If not, then we just will continue with second iteration with a minimal lag. As you can see, it takes us 3 seconds to start second iteration, but these settings also can be changed. So what's additionally we can see? We can click on specific table and see the same information about each specific table. So we can see information about each iteration, iteration time, and information about current iteration. Of course, this is really small amount of data, and iteration does not flows really fast. And you can see that we already passed 30 iterations, and this number will not be stopped. So now let's move on and let's start doing something. But before it, we have a couple of buttons. Let me explain them. So first of all, you can stop and pause, and you can do it for whole scope or on separate tables. So what does it mean? If we'll click on stop, we will stop current iteration and lost all progress of current iteration. So if you're already running the whole first iteration, which took hours to complete, and you will click stop, you will lose the track and you will lose the progress. And pause instead of scope, instead of stop, does only pause the current iteration, and you will not lose any progress of current iteration. So, for example, if we'll just shut down target server or source server, our tool automatically will pause current iteration, and as soon as connection will be going on after it, we will continue from the point of interruption. So, for example, let's pause one table and see what will be going on. So, as you can see, we paused and we have pop out error or message saying that you can proceed to the next iteration while any table is paused. The same pop out message you will have if there will be some problems, if you will get any error. What does it mean? As I already mentioned, we guarantee that at the target database, we will have at the end of the iteration, we will have consistent state of data as it was in source database. But imagine if you will pause one table, this means that next tables will be going on and will be moving forward. But for this table, we will have state which can be not consistent. And that's why we will not start new iteration until one table is paused or errored or something like that. And here we have two different ways of dealing with it. In order to move forward, we need to unpause this table or get rid of error if it will be error. Or we can stop this table, and in such case, we will delete current iteration progress for this table and move on with next iterations. But we can click on Start Post Tables, and we will be able to continue with new iterations. So as you can see, now it's iteration 48, 49, and so on. So it's important to understand that if you will post something, you will not be able to proceed until you will stop this table or unpause it. And the same with error, until you will fix this error or you will stop this table and try to resolve. The same we can do with stop button. We can stop specific table or the whole scope. And for such cases, you will not need to do anything without the tables because iteration flow will be continued. But this table will be stopped until you will run it once again, and then you will go forward. So now let's try to change something in the source database and see how our tool will reflect. So first of all, let's insert some data in the tables and see how our tool works with insert. So let's insert 1,000 additional rows in the first table and 1,000 additional rows in the third table, let's imagine, and see what will be going on. So as we can see, some progresses are started. We can see that a number of total rows and absorted rows will be changed, and we will see some progress. And now, yeah, we will do the same with the third table, but it's because we have looks like we not managed to update this within one iteration. So we did it within 2 iterations. And now we will continue to do everything as previously, because right now we do not change anything. And see, total number of rows is 7K already. We insert 7K, and these iterations, we can even zoom in these graphics. We can see that on 61 iteration, we insert 1K, and here we insert another K in another table. And it also reflects on the time of iteration. We also can go to table number 1, see what is number of inserted rows during this iteration, and the same for table number 3. And also, of course, we can check count in target database. So we have 2,000 rows in Postgres, 1,000 for table number 2, because we didn't insert additionally 2,000, 1,000, and 1,000. Of course, it's absolutely the same as in source right now. So everything will be replicated as needed. Now let's see how our tool works with update. So for this, we have table number 2 with short strings. And as you can see here, we have like random data. And let's update this data in the source database. And let's also check beforehand. In target database, we have absolutely the same random data. And now let's update this data by adding prefix QVE to the first 99 rows in this table. So let's do this. Now let's review the data. So as you can see, we add this prefix to the first 99 rows, and other rows were untouched. Now we can go to our tool and see what is going on. So we can either try to check it from this list, or we can go to table number 2. It will be easy. Yeah, as we can see here, during one of iteration, we understand that something is changed, and we updated 99 rows. And we can see total information about it, and so on and so on. And also we can go to Postgres and see how data changed. Let's select it, and we can see that 99 rows have the same prefix and other rows untouched. So that's how we reflect on update, and with delete we have absolutely the same. Let's delete 500 rows from table number 3, and we will see that we will do the same in target database. Just we need some time until we will complete our iteration, and here we see that during one iteration we have deleted 5,000 rows, and the same we can see inside of this table. And also we can see that total rows right now is 1.5K. We inserted 2K, and we also deleted 500 rows. And of course, right now, number of rows will be absolutely the same, 1.5K, and in Postgres, we have the same amount of rows. Yeah, that's how we're working, but before finishing it, let me also try to emulate work of real database. So I will run stored procedure, which will insert 20,000 rows each 10 seconds for the period of 1 minute. So we will, in total, we will insert 100K rows in table number 1 within 50 seconds. Batches will be 5 batches by 20K rows. So let's start it. We will insert, and we will see how our tool will work with it, and what will be the state, and how we can see what is going on. So let's go to the main page, and here we can see that something's starting to change, and we have some peaks and spikes. And also for this table number 1, we see that amount of data migrated started to increase. We already migrate 100 megabytes, and it will be increasing until we will finish the process. Right now, we are still inserting the data in the source, and our tool, meanwhile, replicating these changes to the target. So you can see that we have some spikes, we are performing some migrations, and of course iteration time starting to increase because we starting to replicate rows, not just empty iterations. So let's wait a little bit more. So we are still doing this in source database. Yeah, right now we finished it, and so right now let's see how much time it will take for us to finish those iterations and to replicate all these changes. And in table number 1, right now we have 102K lines of code, I mean rows of data. And let's move on to IDM. We are still doing some iterations. We are still upserting row, finishing our iterations. And soon we will have the same exact number of rows in target database. So let's wait until we will finish this process, and we will see what is going on in target environment. So let's go to Postgres, and let's select count of rows, and we see that this number are absolutely identical as in source database, and we already replicate all changes in the target database. And now we just continue to have like empty iterations, but these spikes like replicate all these changes within a couple of iterations. And of course, if we was doing it in one commit, then it will be only one iteration. But since we have like 5 commits, then it leads to different number of iterations and total rows here. So that's how the tool is working. This tool will be working on background. You can close it and then reopen the project, and you will have the same graphics, the same statistic, and so on. And as you can see, also data migrated is around 1 GB. So because we moved huge insert from one table to another. So the process is already stable. You will be able to run it anytime. You can close this UI, you can turn on your PC, but because the process is running on background, it will be still working on PostgreSQL and Oracle side. And now how to finish the process, we have 2 buttons. You can stop and current iteration will be stopped, but also we have soft stop button. And this stop means that we will soft stop it. The main idea here is that if we are performing and using our tool for one-time data migration, you will start using it on production database where still transactions is going on. Then when it's time to cut over, when your source database will be switched off for a small period of time, you will click on this button, and this button means that we will finish current iteration and one additional iteration. And this will guarantee that we will synchronize source and target data. So by clicking soft stop, you will be initialized, finalizing process, and within 1.5 or 2 iterations, it will be finished and stopped automatically. This means that you are done, you are finished with your migration, and you can finalize your process and do a cutover, and data is synchronized. Yeah, one more thing which I want to show you. Of course, we have data in the target, which is absolutely the same as in source database. But during the process, our tool also creates set of metadata on PostgreSQL side. So let's refresh it. First of all, tool automatically creates connectors. You can see it here. This is connectors for Oracle FDB, for Postgres FDB, and also we create one additional schema. This is meta schema with some additional tables, and of course, all of this will be cleared after our tool will finish with this current process. How to clear it? It's pretty easy. You can go back to the projects and click delete this project. And as soon as you will click it, our tool will remove all unnecessary data in Postgres. So let's refresh it, and only tables with data will be left. And the same with some connectors. So everything will be cleared. You will left with synchronized data, and you can move forward with cutoff. So that's probably all from my side. I hope you enjoyed it. Believe me or not, but we think that this migration tool and this replication tool is much better than any tool which you know, because we do not utilize redo logs. This is absolutely new technology, and for some strict databases, it's much better technology rather than try to convince your database administrator to change the settings on production database. It's not possible. For our case, just create user, give them a little bit of read privileges, and you're ready to go. You don't need to change any options on Oracle side. Yeah, Christina, that's all from my side. I give a floor to you.
Alex, thank you so much. That was so impressive. Guys, what do you think about this solution? How do you rate the impression from this presentation? You can rate from 1 to 5, where 1 if you didn't impressed, and 5 if you're impressed as I did. So please share your impression. We need your support in chat. You could share your hearts, your likes, your comments and thoughts. We would love to hear them. Also, okay, Alex with us right now. Alex, I noticed one comment that the presentation was impressive, It's just because you're a great speaker and your presentations always incredible, just incredible. Awesome presentation, wonderful, great. Thank you, Alex. We have in comments. So, Alex, thank you so much.
Yes, thanks for kind words, Christina. Yeah, let's answer on some questions.
For sure, it was my next point. We have a couple of questions in the chat. Can you see them, or should I read them aloud?
Yeah, please read them.
Okay, the first question, does your tool correctly understand data types such as number without restrictions, arbitrary precision, raw, B-file, XML type, object types, nested tables, arrays, spatial, and also flashback data?
Yeah, that's a good question. Actually, our tools support pretty much every single type that you can create on Oracle. Of course, we do not support some really like non-default types, and I believe SDO geometry is one of them, but you need to understand that we have wide range of possibilities of changing the data on the fly. So we can provide any formulas on the source side or on the target side when we insert the data, which can change the data itself. So it allows us to support even non-supported data types. So we can change this data on the fly in any way, and for example, provide any SQL formulas in order to extract this SDO geometry to some, for example, text format or other format, binary format, and then when we will load this in the target, also somehow change it so it will be loaded in appropriate columns. So the answer will be yes, for sure, because we have possibility to change data on the fly, and it's already supported.
Thank you, Alex. The next question, does it work Teradata as a source?
So right now, as I already mentioned, we support only Oracle to Postgres, but the main idea here is that we can try to create the same algorithm, the same scenario with different types of MVCC databases. And of course, we have plans on expanding this list of sources and targets. Maybe Teradata will be among them, but like in short plans, we don't have such plans to create support for Teradata.
Thank you so much. And one more question for you, Alex. Will sensitive data be passed through third-party server?
So maybe I don't really get these questions. Our tool does not work with any third parties. So we connect straight from Postgres to Oracle database to source database. And if we're speaking about some sensitive data, because of such architecture, you can be sure that we will pass through the network only one time when we need to move from source to target. And there is no third party. This is straight connectivity from source to target, and the process is totally controlled by Postgres. And you can be sure that your data will not flow anywhere else. UI, which I showed to you, this is just to control the process, web-based controlling the process. How we can use this for testing? I see additional questions. So actually, this is tool not for testing. This is tool for data movement and for synchronization between source and target. And the question can be how the tool tests that data is migrated correctly. And that's actually a great question. And we have plans. And we will release for sure during this year some additional possibilities to test the moved data with different scenarios. So we will like incorporate data validation mechanism in the tool, so the users will not be only to move the data, but they will also be able to test the data with different scenarios. So yeah, the answer like this.
Thank you, Alex. Guys, if we didn't cover your question and you still have question in your mind, please reach out to us and we will respond to it in our private conversation. Yeah.
Christina, I believe the question how we can use it for testing means that how our speaker can test this tool in their environments, I believe, right? So
it was my question actually.
Yeah.
I mean,
okay.
I will have intention to ask the similar question at the end of the session, but of course, please go ahead, Alex.
Yeah. So this tool is already available for everyone to test. So what you need to do is just need to go to our website, ispirer.com, and reach out to our manager team, to our support. Just write, hey, I was on webinar. I wanted to test IDM really huge. So just reach out to us and we will provide you with toolkit itself. So it will be desktop Windows application, just install it. We will provide you with demo license key, with trial key, and you will be able to run it against any of your environment, against any database. So it's not a problem. Just reach out to us and we will provide you with all instructions and trial key so you can test it.
Thank you, Alex, for covering this part. So I don't see any questions in chat. So I believe this session can come to its end. And we really appreciate your time and participation, your great questions, and also involvement in the process that you left your emojis, your questions, thoughts, impressions of this session. And we hope that you enjoy this session as we did. And see you soon, and goodbye.
Yeah. Bye.